Are we live? Are we live? I think so. Good morning, good morning, good morning. Hope everyone had a great weekend. Welcome. We have, I think, what, this is our last full week? Our last full week, I believe, of formal instruction. I know that students are still expected to appear from now until the end of school, but per the calendar, I believe that this is the last full week of regular instruction, if you will. So let's see who's out there. We're getting there. Okay. Let's test the board. Let's see if it's working. Let's see. Hmm. Okay. So I'll wait for more of you to join. Welcome, welcome. The board is live. Welcome, welcome. Welcome, welcome. See who's out there. Still waiting. Welcome, welcome, welcome. While I wait here, let's see. I got to meet my cousin's new puppy. Oh, that's nice. I went to the beach. Awesome. I should have a personal moment of trust with someone I know and have to be back to. Oh, thank you, Josh. That's nice. I celebrated my 17th birthday. Wow. That's awesome. Big deal. Birds made a nest by the kitchen window. Cool. So, hello to everyone out there. Hello, hello. Good morning. So, we'll wait another few minutes. And then we'll begin. But I'm going to post a question that I want us to work on this morning. It's going to be slightly different. Slightly. Not too different. Hold on here. I hope this works. Will this work? Okay, so I'm posting a question here to the chat. Hey, good morning, Leanna. How are you? Good to see you or read your good morning message. So, as usual, just when you can, please just check the board to see if it's working. I'm going to be posting a question here. And this is the equation. So I'm going to have it also on the board. Just let's make sure. Good morning, Sarah. Ladies, if you don't mind, if you can just confirm that the board is operational. Let's just make sure that the board is working, so this way I can just continue with this problem. So the board is live. I just need someone out there to confirm that they can see the statement that I wrote, and then we'll begin. So anyone out there, Leanna, Sarah, if you can just confirm that the board is working, so this way I can begin going over this question. Because this question is not on the review sheet, and I just want to make sure that we can answer it. Good morning, Ethan. So Ethan, if you can just double check to make sure that the whiteboard is working, because I want to go over a question that's not on the review sheet. Let me edit this. We made it. That is correct. We made it in so many different ways, right? With everything that's going on today, you know, we're making progress. That's all I can say. We're definitely making some progress, and we made it here. You know, if we're just speaking about this class in particular, you know, we started off this semester. I want to say what, end of January, early February. We were together for like a month and change, and then you know, we transitioned into this environment, and you guys had to go through a lot of stuff. You know, everyone did, and you know, 2020 is an interesting year to say the less. So the fact that we're here today, you know, being able to do this, and with all the social things that are happening in the world, and the progress that's trying to be achieved, you know, we're making it in many ways. So I just wanted to say that, to comment, if you will, on what's going on. So we're making it. We're moving in the right direction. So let me put this up. So again, the instructions are, I'm going to rewrite the instructions in the chat in case they were a little confusing. Okay, did I go over? I went over. Hold on. Okay, so I'm just going to rewrite this here. And the equation is written there on the chat. Hopefully you see it. I'm going to write the equation here. So we have a function r of p, and that's going to equal to negative 1/2 of p squared plus 1900p. So basically, what we need to do, hopefully you read the question. So the question says the John Deere company has found that the revenue in dollars from sales of riding mowers is a function of the unit price P in dollars that it charges. So if the revenue R is, so this is R, this equation, what unit price P should be charged to maximize revenue? So let me see if I can remove this, and I'll make it a little bit clearer. So let me do this. So you can see a string of messages now. So this is how it should read. So again, John Deere, I'm not sure if you guys have seen these types of lawnmowers. They're kind of industrial or high end. You can it almost looks like a little like tractor, like a mini tractor, if you will. And it's meant to mow, acres of lawn, if you will. So a lot of lawn to cover that a typical lawnmower, it wouldn't cut it. And no pun intended. So, um, so in this example, what we want to know is, so again here, the John Deere company has found that the revenue in dollars from sales of riding mowers is a function of the unit price P in dollars that it charges. So here again, so these machines are pretty expensive. They're not cheap. They're maybe like $1,500 to $2,000. Like you have to imagine the size of this thing, right? And they're gas powered. They're industrial, rugged. They're green. I'm not sure if you've seen them, but I'll post a picture later. But anyway, so here's the equation that represents their revenue, if you will. So if the revenue revenue is a function of price, which equals to negative half P squared plus 1900P, what unit price P should be charged to maximize revenue? So in other words, you're a company, what price should we charge so that we maximize revenue? And what is the maximum revenue? So if you were to plot this, so we should look at this, from Desmos. So if I were you, I'd put this into Desmos so we can take a quick look. You may have to zoom out just because of the parameters here. So negative 0.5, you can put x squared plus 1900p, excuse me. So it's kind of hard to see. All right, yeah, you need to like zoom out, like completely. Like this is insane. Wow. So if you try using Desmos, right, this is where you're going to run into problems. Because if you just leave it with the given intervals, right, so if you do something like this, and you just plug in the equation, you're going to see something like this. It's just like a thick line, and my line is so bad. So just something like this. That's what it will look like. That is of no help to anyone. So if you have a graphing calculator, you can do zoom fit. That could work, but if you're looking at Desmos, you have to scroll or zoom out, if you will. So if you zoom out, it will end up looking something like this. And this is just an exaggeration. This is a complete exaggeration. So it'll look something like this. You'll have your parabola, right? And it's negative because, or it is upside down, if you will, because of that negative coefficient within the x squared, or the variable that's raised to the power of 2. So if you find this confusing to process, to compute, so basically what we're trying to find is the maximum point of the parabola. But in order to do that, and if you find the computer to be really, really difficult, you find the minimum or maximum point with the axis of symmetry. So that's part of it, right? So if we look at the equation, so let's write it in here. So we have what? What is it? R of P, but we can pretend that that's X for now, is equal to negative half P squared plus 1900P. So we have to identify our A, B, and C values. So A here is negative half, B is 1900. We don't have a C value or a constant, which is okay. We can say that it's 0. So we're going to substitute this into the axis of symmetry. So yes, we have X, but if you'd like, we can write it as P just so that we're consistent. So what do we have? B squared. B squared says 1900, right? Is that what we have? Let me just double check. Okay. So if we plug this in, so we have here 1900, right? But remember, it's negative. So negative all of this, right? And then we have that divided by 2a, but a is negative half, right? So if we do this, we have two negatives, so that becomes positive. But then a half with a 2 times a half, you just get rid of all this and you're left with 1. So it's just a coincidence here that the price where you're going to maximize revenue, $1,900, is the B term, if you will, or the coefficient of the linear variable x. So what we need to do now is basically, if we are going to sell, if we're going to sell these units at $1,900, we want to figure out what our revenue is going to be. So we know that we have R, which is revenue, but the revenue at this price of 1900. So what you need to do is you have to plug that in to your formula. And you need to evaluate. So I'm going to give you a moment to evaluate this. So if you did this correctly, your revenue, when you have a unit price of 1900, let's see here, you should have about 1,805,000. So again, if just rereading the question, it says the following: if the revenue R is, and it's given by this equation, what unit price should be charged to maximize revenue? And then what would be your maximum revenue at this price? So again, you know, some things here to consider. You don't really know how many units you have per se, right? But and again, where this formula comes from, this is just a combination of factors, right? And it's kind of a deeper conversation, right? If you think about the costs that go into, well, that's a separate equation also. Cost, you know, then you talk about profit and things like that, but how this is all generated, it goes into, you know, the actual details of a business, which is a little bit more complex for our discussion right now. But the revenue function is given by this equation. But you can do this much easier. So if you have Desmos, and maybe some of you already did this, if you found the maximum point using Desmos, you had to really zoom out with the graph. You would have seen something like this. And I'm looking at it now here. So this point was given to you as the maximum. So in other words, what you're really looking for here is the vertex of this parabola, because that's the tip, right, or the turning point. So after that point, there's going to be a change. In this case, things are going to decrease. But here at this point, It's a maximum value. And what does this maximum value represent? So in this case, this is P, right? And this is the output, R of P, right? So when we charge 1900 for this lawnmower, that's our expected revenue. Let's see, any questions? Have we discussed how I'll be taking the final exam? I missed out on a few classes. So, let's see. So the final exam is tomorrow. The final exam, I believe I'll make live like 8 a.m. Right? It'll be live 8 a.m., but it begins when you start. So if you start at like 9, I believe, 10 if you will, from the moment that you start, you have 2 hours to complete it. And that's basically it. Once that 2-hour window is done, the exam closes. And whatever work you have submitted, that's the work I'm going to grade. So again, you're going to be taking the final exam through Lumen Learning. You'll log in tomorrow. It'll be posted live. And you'll have 2 hours to complete it. Hopefully you went through the sample final exam where you had to go and answer some questions, input some values, upload some work. And you just have to be careful with the pictures that you're taking, because I know that some phones, I think the iPhones, they have a new file format for their pictures, so there could be issues. Excuse me, when you're uploading this work, could be. And again, hopefully you didn't experience any of those issues. So if you haven't done so, I would highly recommend that you go into Lumen Learning, that you work on a couple of practice problems, and then you upload that into Lumen Learning to see how it works. And also it's good practice with inputting values into that system. It's very similar to how you would have completed homework on Lumen Learning. I hope that answered your question, Kyle. Okay, so let's just double check here. So if you have any questions, please post them. But just so you know, the review that we've had since the beginning, I think we've been reviewing now for about over a week. If you look back at the whiteboards, at these videos, just for some detailed explanation, those questions are definitely questions that you should be focusing on. I'm trying to make the review more focused, if you will. So this way, you're not over preparing, if you will. But you should be able to answer all of the questions that are on that review sheet. We went over a lot of stuff. So just to make sure that we have this, let's see. Hold on. So let's see how we'll do this. Okay, so what I want here, so I'm putting something up on our board, and I want the exact value of this. So given cosine 5 pi divided by 4, I want the exact location of this on a unit circle. So, what is the corresponding point on the unit circle? So again, I have a question that I proposed up on our whiteboard. So it's cosine 5 pi divided by 4. So what I'm asking for there is the exact location. So what quadrant is it in, and what's the xy value? So what I would recommend doing is creating a unit circle. Right, create the unit circle, but also that would require the coordinate plane. Remember x, y. Don't forget all students take calculus, right? So an idea of where that is, right? You have to figure out the radian measure and convert that to degrees. So at 9 a.m. tomorrow, it will be available to do on Lumen Learning. Yes, Leanna. I'll probably post it earlier. In theory, I could post it after this class, and if you finish it, you finish it. You know, that's completely up to you. But I think it will. I think we'll feel better knowing that it's tomorrow. You know, this way you have another day to prepare. Just go through the problems, the examples, and you should be ready to go by tomorrow. But yes, to answer your question, 9 a.m. the exam will be live. But it begins the moment that you start the exam. You start the exam at 10, it will begin at 10. You have 2 hours to complete it. I don't believe I'm going to have it so that it must start at a particular hour and then it ends. I think I'm going to be flexible with that. I just have to double check. But by 9 a.m. tomorrow, it will be live. And I recommend that you get it out of the way. That would be my advice. Do it at 9 a.m.? Yeah, that sounds good. Thank you. Okay, no problem. All right, so I want you to work on this question here that I proposed. So again, I gave you cosine of 5 pi divided by 4. I need to know where this exactly is on the coordinate plane. I need to know the quadrant, and I need to know the corresponding point that relates to this trig function. So I'm going to give you about 2 minutes. So you should be able to convert this to degrees. Then you'll know where you are on the coordinate plane. You know the value of x and y. And then you'll be able to find exactly each component of the right triangle. In other words, what the length of one leg is, what the length of another leg is, the angle measurements, right? Reference angles. You should be able to do all of that. And this should take you about 2 to 3 minutes. So I'm going to give you about another minute or so to finish this up. All right, so let me help you a little bit. So we need to figure out how many degrees are in 5 pi divided by 4. Don't forget that pi is 180, right? Pi is 180 degrees, so don't forget that, right? So we have the conversions, right? Going from, so we have 180 pi, or 180 divided by pi, and then we have pi divided by 180. So this is to convert to degrees. This is to convert to radians. Right, so we want to convert to degrees. So basically the pi's are out, and then we have the following. So we have here 5 pi divided by 4 times 180 divided by pi. So pi's are gone, and then we multiply. So what is 180 times 5 divided by 4? Right, so you should have here basically 45 times 5, which should just be 225. So hopefully you have that. So basically what we're looking at now here is cosine of 225 degrees. So hopefully you have that. And when we relate it to the coordinate plane, right, so here we have x, y. So we're definitely past 180, but less than 270. So we're somewhere here. So since tangent is positive here, right, don't forget tangent is positive, cosine is going to be negative. But what's the corresponding acute angle here? So what's theta? So if we subtract 180 and 225, you should notice that you have 45 degrees here. So theta is equal to 45. That's supposed to be 45 degrees. So if that's the case, right, this is also 45 degrees. And what we need to do is figure out essentially the length, right? So with respect to this angle, we need to know, we can find cosine, right, what that exact value is, but also the corresponding coordinate. So let's first of all find out what cosine of 225 is. It's the same as the cosine of 45. But if we have our right triangle, remember this is the unit circle. Unit circle. So if our radius is 1, right? Radius is 1 in the unit circle. So what we need to do now is you have to figure out what the length is of everything else. So hopefully you remember that this is radical 2 divided by 2. But now the issue is this, right? So here you have cosine of 45. It equals to radical 2 divided by 2. But since we are in the third quadrant, this thing's going to be negative, right? But you have to think about x and y, right? When we're dealing with a unit circle in trigonometry, what is really x and y? So I'll give you about 30 seconds to think about it. How do we rewrite x and y with sine and cosine? All right, 10 more seconds. So remember, x is really cosine of theta, and y is really sine of theta. So since we have both here, 45, 45, 90, the legs are the same length. But since we're also in the third quadrant, these are going to be negative. Cosine is negative, and sine is negative. Let's see what else we have here. So hopefully you found this to be a little helpful, right? A good review of this part of the chapter or the unit or the material that we've covered. Just give me 1 second. Okay, sorry about that. So I guess it kind of sounds like Skype, I think, right? But anyway, that's Microsoft Teams. I ignored the phone call, kind of. Anyway, so where was I? So we went over that sine, cosine, tangent. Hopefully that was helpful. I hope you can go back and look at the steps as to how I got there. The only thing that's like not ideal is the fact that it's 45, 45, 90. right? So you probably would want to see an example where it's like 30, 60, 90. So if we just look at one quickly, what if we did 5 pi, so I'm just making this up. So what if we had sine of 5 pi divided by 6, right? So you should already, just by looking at this, you know that it's not really 180 degrees, right? It's 5/6 of pi. So when we divide that, right? So then converting, it's really 5 times 180 divided by 6. 180 divided by, right? So here we have 30, so it should be 150 degrees, if we think about it. So hopefully I didn't go too fast there. So here, we have sine of 5/6 pi. That's going to equal to sine times 150 degrees, or of 150 degrees, excuse me, not times. And if we draw this out on the coordinate plane, right, x, y, x, y, right, we're somewhere here, but if we create our triangle, remember, all students take calculus, right? So we're going to find the exact value of sine, but we're also going to find where this is located on the coordinate plane. So there's theta, right? So, but if this whole thing is 150, we need the acute angle, so this becomes 30. So 30, 60, right? And then obviously there we have 90. Remember our unit circle, 1. Opposite 60, right? Don't forget, opposite 60. So here we have half, right? Opposite 30, we have the smallest side of the right triangle. It's half the length of the hypotenuse. So if the hypotenuse is the length of 1, half of that is half. But don't forget that opposite 60, it is radical 3 times larger than the smallest leg. So when we look at this, I'm going to just detach it now completely, making it a little bit bigger so you can see. Here's 30, that's what we care about, right? We said this is half 1 radical 3 over 2. So what is sine of 150? It's the same as the sine of 30, excuse me. What's sine of 30? Half. But now the question is this, is it positive or negative? Since we are in quadrant 2, right? All students take calculus. All students take calculus. So sine is positive. But what I want us to do, I want us to find the exact location on the coordinate plane. So if we do x, y, we know that's the same as cosine theta and sine theta. So the exact position of this, we know that this is half, right? That's the value of sine theta. However, if we're going to look at cosine, it's adjacent, right? So cosine 30 is the adjacent side over the hypotenuse. The hypotenuse is 1, so it's radical 3 divided by 2. But it must be negative because only sine is positive in quadrant 2. So hopefully that makes it a little bit clearer. So it's again about converting the radian measure to degree. Once you're in degree, you figure out where the terminal side is in the coordinate plane, find the reference angle, and then label appropriately. So hopefully that's a little bit clearer. All right, so let's look at this question. This is the last one. All right, so let's look at 15. So it says here Maria invested a total of $31,000 into 2 accounts. The first account earned 14% after 1 year. However, the second account suffered a 10% loss in the same time. At the end of 1 year, the total amount of money gained was $1,700. How much was invested into each account? So, account 1 is X, account 2 is Y. Together, in these two accounts, there's $31,000 invested. Are you with me so far? All right, so we'll call this account 1, and this is account 2. Combined, $31,000. But the first account, right, it earned 14% after 1 year. The second account suffered a 10% loss at the same time. So now the question is this. So how do we write this? There's a couple of ways that you can write this, right? So if you're going to earn 14%, right, you'll have here. So we can look at it this way, right, because that's 14%. And then here we have 10%. Right, but now here's the thing. There is a gain of 14 and a loss of 10, so the 10 is negative, right? But when you combine the efforts here, you'll have a total of 1,700. So since this is a system of equations, I'm going to let you figure this one out. Just because of time. So if we look, so that the setup is the hardest thing, right? I'm sorry, I forgot the most important pieces. So here we have X and Y. So sorry. So if we look here, I have the review sheet that should be shown. It was 15, excuse me. So let's look. This is 15. So look at what the solutions are, right? So there's many ways that we can do this. We can do substitution, right? We can do elimination. For this particular example, maybe I would eliminate with the y. I want to get rid of the y because it's already negative. So what you could do then, so I'm just going to set this up. So I'm going to rewrite this top equation here, and we're going to multiply the whole thing by 0.10. Right, so then here you have x, here you have y, here you have 31,000. So if you distribute this, then you have the following. You have 0.10 x plus 0.10 y. That will equal to 3,100. But then you have, so 0, right? 0.14x minus, and this is what? 0.01y, and this will equal to 1,700. So if we solve here, 0.24x, and what is this equal to? 4,800? And then if we solve, we have the following. So what does the solution say here? X is 20,000, I believe. So if you solve, this will be 20,000. And let's see if that's correct in the solutions. Yes. But you already know that x plus y equals to 31,000. So if you have something like that, then you know that y will have to be that difference, or 11,000. So we went through, in how do I place, or how do I say this? We went through a lot of questions. We went through a lot. The questions that we've gone through, if you look back and prepare those and focus on those, especially the one that we covered today, the one with John Deere, go back, redo them, make sure that your answers match. I think you'll be in a very good place for tomorrow. Do you have any last minute questions before we wrap up today? So just so you know, this is the last class where I'm reviewing or going over anything. Tomorrow, I'm not going to do YouTube Live, nothing like that. I'll just post something in the stream saying, hey all, the exam is live, good luck, and it was a pleasure teaching you this semester. So basically, this is the last live chat that you'll have with me, this year. This is my last, real class, if you will, at Academy. I'm not coming back next year. That's it. So for those seniors that are leaving the school, I'm leaving with you. For those juniors that, have one more year left at Academy, I'm definitely going to miss all of you guys. Again, Academy was my home for a very long time, over 10 years. I miss it. I think about it often. And, sometimes it's just time to move on, but never forget, where you come from. So that kind of deal. But it's been a great pleasure, a great experience. Clearly I'm in, a different place now. I'm really happy where I am, but it's because of all those experiences from the past that, I'll be able to move on and to grow from that. And I hope that everyone here can do the same. And thank you, Brittany. So with that, that's it. That's it. Thank you, Sarah. I miss everyone. I hope everyone is doing well. I hope everyone studies and prepares. And again, I'll be around. All you have to do is send me a message. And no one really has. No one has messaged saying, hey, can I have help with this particular problem? Which is a good thing. I'm hoping that you understand it all. So I guess that's a good sign. But again, if you need assistance, I'll be available throughout the day. Just shoot me a message. If not, I'll see you tomorrow morning on the stream. Good luck. Remember, you're going to have 2 hours. And make sure that your phones, or however you plan on submitting work, that everything is functioning, that your laptop is charged, that your phone is charged, everything is ready to go, that you have scrap paper so that you can do some of the work, and that it's clear work so that if you do take a picture and submit it, that I can understand it. So on that note, good luck. I'll see you guys tomorrow on the stream, but this is the last time that I'll be teaching you. So with that, I'm signing off. It's been a blast, guys. Miss all of you, and good luck. See you later.